Exercise 9.17. Figure 9.35 shows a cross-section of a light pipe made up of a glass fiber of refractive index 1.68. The outer covering of the pipe is made up of a material of refractive index 1.44. What would be the range of angle of incidence rays with the axis of the pipe for which the total internal reflections inside the pipe takes place as shown in figure B. What is the answer if there is no outer covering of the pipe? So here we have to find the range of this angle of incidence over here. Okay, here it is given that refractive index of the glass fiber is 1.68. Let it be n1. So here n1 is what, 1.68, and the refractive index of the outer covering, this outer covering, let it be n2. So n2 over here is what, 1.44. Okay, so here in the solution, okay, let n1 is 1.68 and n2 is what, 1.44. Okay, now here we can say let this point of incidence inside the glass fiber is B. Okay, so here we can say at point B total internal reflection would take place if the angle I dash, which is the incident angle over here, must be greater than what, critical angle. So here we can say for TIR to takes place at B, I dash must be greater than what, critical angle IC. Okay, so first we will find the critical angle at point B. We know that the angle of incidence at which the refracted ray becomes parallel to surface and refracted angle becomes 90 degree. That angle of incidence is called critical angle. Okay, so first we will find the critical angle. So here I can say for critical angle over here, we can say n1 sine IC is equal to n2 sine 90. So we can say sine IC is equal to n2 by n1. N2 is 1.44 over here. Okay, and n1 is what, 1.68. Okay, so on solving this, you will get the answer 0.8571. That is what, sine IC. So IC is nothing but sine inverse 0.8571. So it is a 59 degree. So IC is 59 degree. Okay, so here we can say total internal reflection would takes place if over here I dash at point B, okay, which is angle of incidence is greater than what, 59 degree. So for total internal reflection we can say I dash must be greater than what, 59 डिग्री. अभी आई डैश की बाकी जितनी भी वैल्यूज है, ठीक है, जो 59 डिग्री से ज़्यादा है, उस सब के लिए क्या होगा, टोटल इंटरनल रिफ्लेक्शन होगा. तो आई डैश को अगर हमें जितना हो सके उतना इंक्रीज करना है तो ऑब्वियसली उसके लिए आर जो है वो हो सके उतना छोटा रखना पड़ेगा. ठीक है, तो चलो फाइंड आउट करते कि आर कितना मैक्सिमम परमिसिबल है, मैक्सिमम अलाउड कर सकते वो. ठीक है, आप देख सकते हो सपोज ये ट्राइंगल क्या है, ए बी, और इसको बोल देते हैं पॉइंट, लेट इट बी ओ. Okay, so in this triangle OBO you can see that this angle is what, 90 degree. So R is equal to nothing but 90 minus I dash. Okay, so here we can say maximum permissible refraction angle, the refractive angle R max is nothing but what, 90 minus I dash. That is nothing but 90 minus I dash. That is a 59, which is maximum, we can say, below which the critical, or you can say below which the total internal reflection would not take place. So I am taking over 59 to find the maximum permissible value of R. So 90 minus 59 becomes what, 31 degree. Okay, let, we can say, maximum angle of incidence. Okay, over here is I max. Let I max is maximum angle of incidence. Okay, so using Snell's law at point A, we can say, using Snell's law at a point ए पॉइंट पे, यहाँ पे स्नेल्स का लॉ अप्लाई करेंगे तो क्या होगा, n1 sin I, here n1 refractive index of this medium, let it be 1. So here I am taking, instead of n1, na, because here we are talking about a air, and A sin I is equal to refractive index of medium, which is inside the core, over here is n1 sin R. Okay, so here Na, refractive index of air, is 1, that is equal into sin I is equal to n1. N1 is the 1.68 into, we have sin R, that is what R is, we know that 31 degree over here. Okay, here we are finding the maximum angle of incidence. Okay, so it is Rm, this one is Im. Okay, so sin Im on multiplying the value of sin 31 and 1.68, we will get the answer 0.8662. Okay, so we can say Im is sin inverse 0.8662. Okay, so Im is nothing but, we can say, nearly about 60 degree. Okay, that is the maximum angle of incidence. So here we can say, so all the rays, okay, which are, all the rays which are incident below 60 degree, मीन्स व्हाट, 0 to 60 डिग्री में जितने भी इंसिडेंट होंगे तो सबका क्या होगा, टोटल इंटरनल रिफ्लेक्शन होगा. सो हियर वी कैन से ऑल द रेज विच आर इंसिडेंट, ओके, between 0 to 60 degree, okay, TIR, total internal reflection, will occur. Okay, now let's see part B of this problem. What is the answer if there is no outer covering of the pipe? अगर यहाँ पे जो आउटर कवरिंग है जिसका रिफ्रैक्टिव इंडेक्स कितना था 1.44, वो निकाल देंगे. as there is no outer core in this part B. Okay, so here let the refractive index of the outer side of the pipe is n2 is equal to 1, and that is the refractive index of air. Okay, here I am taking at point O A, angle of incidence nothing but what, 90 degree. Okay, suppose the angle of incidence is 90 degree, means I am taking the maximum angle of incidence. Okay, we can say for angle of incidence I is equal to 90 degree. Okay, applying Snell's law, at point A, ये N2 है तो ऑब्वियसली यहाँ पे जो बाहर मीडियम है वो भी एयर है, तो उसका रिफ्रैक्टिव इंडेक्स 1 है. सो हियर वी कैन से N2 sin I is equal to what? N1 sine r. Okay, so here N2 is nothing but 1, sine I is nothing but 9 sine 90, N1 is that of a refractive index of a pipe 1.68 sine r. So value of sine 90, we know that it is a 1, so sine r is equal to 1 divided by 1.68. Okay, so on solving we'll get this answer 0.5952. Okay, so sine r is 0.5952, so r is equal to, I can say, sine inverse 0.5952. Okay, so it is nothing but, we can say, 36.5 degree. So it is the angle of refraction. This one is r. Okay, now let's find the I dash. Over here in this triangle AB, that this point is O, so you can say sum of this three interior angles is nothing but 180 degree. Okay, this angle is 90. Okay, so we can say I dash plus r is equal to 90. So here I dash is equal to 90 minus r. So it is a 90 minus 36.5. Okay, so on solving you will get 53.5 degree. It is the angle of incidence over here. Okay, this one is nothing but what? Angle of incidence. Okay, here we can say this angle of incidence, which is what? I dash, is, we can say, greater than what? R, is greater than what? R. Here at point B, if we find the angle of critical angle, okay, let's find out somewhere over here. This one is the extra point, no need to write this. Okay, applying Snell's law at point B, we will find over here a critical angle. Okay, we know that a critical angle is the angle of incidence at which the angle of refraction is 90 degree. So that is N1 sine I dash is equal to N2 means 1 over here, and angle of refraction is 90, so sine I dash, you can see that is 1 over n1. Okay, so that is a sine I dash is 1 over n1 over here, this one. Okay, and we are finding the critical angle, so I am denoting it by IC. Okay, n1 is, you can see that 1.68, so 1 over 1.68. Okay, it nothing but what? 0.5952. So our critical angle IC is 0.5952, and it is nothing but what? Our R. Okay, sine IC is nothing but 0.5952, and hence I can say over here that IC is 36.5, and it is our angle of refraction. So in short, our angle of incidence, which is a I dash at point B, is greater than R, means what? It is a greater than IC. Okay, so here we can say as angle of incidence is greater than IC, or you can say as it is greater than R. Okay, so TIR will takes place. Okay, here you can see that initially I already take the angle of incidence 90 degree. For 90 degree, okay, which is the maximum angle of incidence, the TIR takes place. So for all the angles below, you can say 90 degree, TIR will also takes place. Okay, so here we can say as I dash is greater than IC over here, all the incident rays suffers TIR, total internal reflection. Here this one is the extra, no need to write this portion in the solution. Okay.